Hello friends, today we're gonna discuss about MVVM design pattern. So let's begin. What I'm going to talk now is first we will look into requirement of design pattern and then best practices of it. Then we'll look into MVP and MVVM architecture, and then we'll also look the helping framework and libraries available and Android MVVM architecture example. Okay, so let's move next. The first question that is being arise why we required it? Why we required the design pattern? Design pattern requirement. We required the design pattern because when our code becoming complex and it's being distributed among different stakeholders and management of code and streamline everything and in doing integration of it and also catering all the bugs, so all these things are becoming very difficult if we are not using a proper design pattern and also not following the clean architecture. So to overdo all these things, we require to adhere with some design pattern. So why I use the design pattern? Okay, the first thing that's come to our mind most of the time. So the first thing we have to remember, let me change my color to white. Okay, so first of all, reading and understanding of code becoming very easier when we following the design pattern. Okay, if we follow a design pattern, code readability will be getting increased basically. So easier to scale. Okay, if you want to scale up our application, so it will be becoming very easier for us because we are adhering all this thing and we are following some pattern for it. So we follow, if you follow continuously, then we can the code visibility and scalability becoming very easier. Okay, and the next thing is easy to test. Okay, so we can test each and every component of our application, and if we are using a proper design pattern that is being required for the specific condition and scenario. And next, easier to find and resolve the bug. Okay, if we are using some design pattern, then it's becoming very easier for us to find out the bug and also resolve it. Because if let's suppose I'm not using any design pattern and there's a lot of dependency and complexity available inside my code, then if I move something, if I trying to resolve one bug, it might be a lot of possibility it will be introduced many bug inside the code. So if you're following the design pattern, then it's becoming very easier for us to find out. Okay, easier to apply any other languages. Okay, so that means like if we are I'm developing some component that is being uh, let's suppose I have an application. I'm developing it in Java, and if I'm following the design pattern, it is becoming like easier if I'm using some other language like inside I'm using some C++ component. So if I'm following the design pattern and I'm able to use the Java component very easily if I'm using the similarity. If I have writing some code, complex code inside the Java, and if I'm trying to use some classes in C++ using native, then it's becoming very difficult for me because I'm not following any design pattern. So let's suppose I made some changes in Java, it will be impacting the C++ code. That mean also if I'm trying to write something in C++, it's becoming very difficult for Java to update. So let's suppose if I'm using a builder inside Java, so it will be very easier for me to use that same thing and or to use those API and everything in C++ because I'm following some pattern here. I'm following some design pattern specific to the component and my requirement, and that thing also I can extend it with C++ also. Like I'm using builder, I can also use the builder here also. I can continue using extending the component of Java in C++ also is using this that design pattern, and also use some other design pattern. Reducing the technical, absolutely, I'm agree with it. It will be reduce the technical risk, like whatever the risk this is also one risk, like interdependability of like Java and C++ and other component, like it might be possible in future it will be it will be adding the Python also there. So if you want a layer in which we are communicating with them with both these languages, so those things will be like easier for Python and Java. And a lot of things are there that have been done if you are following the design pattern. So let's move to the next thing. So the first question arises in our mind, like what? Okay, people are saying like what is this, like how we can do it, where I can start it, and how I can implement it. Okay, so that is the first thing that's obviously comes to our mind. So first of all, I'm giving you an example. Here you can see I have created a function that is a fast play possibility. Okay, here you can say I have if condition, then I have a for loop, then again I have a for loop, then again if condition, and then if condition. And in this code you can easily say like I have, if I'm making some changes in this logic, it's becoming very difficult for me to manage this complete block. Let me change the color to blue. Okay, it's becoming very difficult. Okay, to maintaining this piece of code is becoming very difficult. And if like other scenarios are come and other checklists are come, then it's becoming very difficult because it is tightly, you can say, the hierarchy went to this if condition, and the leveling is like 1 2 3 4 5 level. Okay, these things, so we have to reduce it. Okay, so to reducing all these things, we have to follow the best practices. Okay, the best practices like choosing a appropriate name, meaningful name we have to use. Don't use the state or obvious. Don't We don't have to use it. Okay. Write as small methods. Okay. The method name try to be small, not so big. Write method that only do one thing. Okay, in the previous example there is a method that is performing a lot of things. Okay, we have to break it down in a smaller piece. Okay, our method should be of like maximum of 10 length. Okay, and it should not be complex, it should be simple. So we have we for okay, this thing and this thing we have done. Okay, encapsulate boolean expression or overly complex code. Okay, we have to encapsulate. Let's suppose there's a complex if condition there. There's a complex if condition is there, so we have to simplify it. Okay, first of all we have to simplify this expression and try to break it down and on making it like encapsulated. Okay, overly complex code. Okay, we also try to simplify it. Avoid deep nesting. Okay, in the previous example you can see we are using a lot of deep nesting is there, so we have to avoid this thing. Replace constructor with builder. Okay, let's suppose I have a one class in Java, and in this class I'm using multiple constructor. Let's suppose I'm using 1 2 3 4 5 constructor I'm using for building this class. Let's suppose in one constructor I'm making it empty, in other constructor I'm passing one value, here I'm passing two value. here 3 values, and here I'm passing 4 values. If it is such condition, so in that scenario we don't have to create multiple constructors, we have to create one constructor, or we don't need the only one constructor. Okay, and we have to use the builder pattern. With the help of builder, we are creating the object of that class. That is that simple. We have to basically simplify our code so that it will be easier for managing it and maintaining it. Use refactoring pattern to fight against legacy. Okay, let's suppose I have a piece of code that is being very old. Okay, I have a legacy code that is being very old. So okay, so the first thing I have to do, I have to change my legacy code and refactor it and make it in a proper way. Make it in a proper way using design pattern, DP design pattern. Next, okay, we'll look into like MVP and MVVM. Okay, so MVP and MVVM, they both are widely used in Android. Okay, previously we are using the MVP, and now we have moved to the MVVM. So I'm giving a brief about like what is this MVP and what is this MVVM. So MVP is a model, presenter, and viewer. In the case of Android, the viewer is your XML file in which you're designing it. Okay, you're designing the UI. Okay, this is your view part, and presenter in that scenario is your activity. Okay, this is your activity, and model is the data that you want to pass to the activity, which will be changed accordingly. Let's suppose in the button click I want to fetch the data. Okay, so I will be click on the fetch data, and then it will be called some repository provide the data and giving you a model, and with that, with the help of that model, you will be making change in the view. That is the design pattern previously we are using in Android. Now we have moved to the MVVM. So inside the MVVM, what we are doing, okay, sorry, I forgot one more thing in the MVP. Here, what was happening in the view? We are clicking one button, so we are doing some event. Some event will come from the view to the presenter, and then presenter update the model. The presenter will update the model. Let's suppose I'm using some counter. Okay, in counter, I'm giving an example of an counter. Okay, don't make it complex. Okay, I will be using the counter. So inside the counter I have creating a pose of I'm creating a model file. Okay, which is saving the current state, like which is saving the count value and the count text. Okay, these two things I'm saving in the model, inside the model. Whenever I'm clicking on the plus button, the event will go to the presenter, and then presenter made some modification in the model. It will be increase the count value +1 and also updating the text, updating the test. Okay, and this thing will be happening. Now the model will be changed. It will be then against went to the presenter. Okay, presenter will see like this and some changes have been done for the model. Then it will be updating the view. That is the flow of it, MVP. And now next move to the MVVM. So inside the MVVM we are using view and view model and model. So basically our view is bind with the view model. Okay, with using the data binding it is being binded. So and view model update the model. This is similar thing is like working as in presenter, but here it is not an activity, it is a different class. Okay, so it is directly being connecting to the view. Okay, in that scenario, let's suppose inside the view I'm clicking some button. Okay, and I'm clicking some button. So inside that button it will be calling the view model. View model will update the model. Okay, whenever some changes will be there, we also getting a notification of it, like with the help of observer. Okay, we are getting creating a data, live data we are using. Okay, we are getting the notification of it, and it's directly being updated. Okay, we don't have to do any extra work for it. Inside in this scenario, in the presenter scenario, we will manually updating the view. But in the case of view model, whenever there's some changes happening in the model side, it will be automatically being updated in the view. Okay, that's why it is calling a view model. And you can say it is a it is a layer between view and the model, and it's cover both view and model, so that it is. So for implementing the design, all these design pattern, it's becoming very difficult. So to overcome it, we have some helping libraries. Okay, that's so the first helping library we are using, that is called a butter knife. I think like most of you already been using it, and if you are not using it, it's not a complex library, it is a very simple library. Okay, and it's make your life very easier. Okay, previously let's suppose if I'm writing some, I'm creating some activity, what I have to do, whatever the things I'm using in the XML file, I also need to initialize it like this. Okay, using the find view model, we also have to link whatever the things we are using. Okay, but in the case of butter knife, we don't have to do such thing. This operation we don't have to do. We just use this annotation, and the linking will be done automatically. We don't have to do anything for it. That is a plus point of it. Okay, and the next library is a dagger. Dagger, I thought like most of the thing, like why, what is the name, but that is the name they have writing, they have like that's come in their mind. So yeah, let's go. So before dagger, okay, before dagger, what we are doing, let's suppose I'm using some home view model. So I have to initialize that home view model, and then I'm using it. Okay, and let's suppose I have some All-in API that I'm using for fetching the data from the remote. Okay, that thing I have to do. But in the case if I'm using the and let's suppose that Alone API will be dependent on some, here it is not dependent, let's suppose it's will dependent on other module also. So it's becoming very difficult to manage all those dependencies. So to overcome this, okay, to managing all these dependencies and everything, now in the case here, okay, we just have to initialize our component only. Okay, and we have to do like this component dot inject this. Okay, and whatever the dependency and what are the things we are using, we don't require to be initialize it individually. Okay, we just have to write it down and add this thing like at the rate inject. Okay, whatever the thing it is, whatever the type of class it is, it's being provided by the dagger will create this class for you. You don't have to do anything. Okay, that's why it is using for DI, dependency injection. This is called a dependency injection. For dependency injection, we required the dagger. And now there's an latest API like Hilt is there. That is a part, Android is managing it, and it is very simpler. It is a lot of simpler than dagger, but it is specific to mostly Android only, I think. Okay, if you don't want to perform all these things also, Android is also providing you, not in the case of dependency injection, we are using butter knife. Okay, if you don't want to use the butter knife, then Android also helping you with this. Okay, so Android comes with the data binding. Okay, with the help of data binding, you are directly injecting the data inside your XML. Here you can say in this case, I'm directly passing my Pokemon view model inside my view model. and also adding it here. Okay. And whenever there's some change happening in this view model, it's being updated automatically. Okay, that is the same thing I'm telling you previously. Yeah, that is it. And the next thing is like inside the activity, what I need to do, I just have to do my binding. For the binding, I have to do like data binding util, set data content, and then passing my activity, and set the view model like this. Okay, and whatever the changes happening inside this view model will automatically be reflecting in my view. Okay, Android data binding framework auto generate the code. Okay, it will be generating the code generation will be done automatically. Just get bind the object and set parameter define it XML. In the XML we have to define like whatever where we want to use that model. Okay, whatever the value we want to change we required, we can make it here. Then XML will automatically get the data from the same thing I have previously told you. The XML file will directly bind with that view model. In that scenario, that is this view model. Okay, whenever some changes will happening in this view model, it's being automatically being reflecting in your view. Okay, next move to the view model. Okay, inside the view model we have to refer the data that we want to manage, and also we are saving the instance of activity. Here we are using the activity inside the view model because some event and some changes, so that's why we required it. In this thing you can say like we are calling get name model will provide you the get name, view model will providing the name of that model. Okay, and also get Pokemon ID and all these things you can see, these things will be providing by the view model. Okay, this is a model, and we also do the custom binding. Okay, let's suppose I'm getting a list of lot of data set, and if I want to reflect it in recycler viewer, so I can also do it. Okay, for that I have to use the custom binding adapter. So that is all the things we have done. Now let's move to the architecture overview. Okay, inside the package we also have to we also manage our package properly, so that we are able to scale up our code. Okay, whatever the component we are working in, we have to adhere it properly. It doesn't mean like the things that you have done in the DI, it should not be in the binding or application. Whatever the things related to the DI should come in this folder structure DI. Okay, whatever the things you're doing in the UI, it should be in this UI. Okay, we have to use it properly, otherwise it's becoming very difficult to manage if your code is getting scaled up. Okay, from the initial level if we are following this, I know like it will be take some time for you to adhere, and it will be take extra time for you to doing a small thing, but if you are continuously doing this thing, it will be becoming, your life will be becoming very easier. And this is the like package organization that we have to do for the binding thing. All the thing that related to the binding should be placed here, and data and DI things will be there, and UI, and if you're using volley, it's like this. Yeah, thank you all. If you have any question, you can comment it out. I will be try to resolve it as soon as possible. Thank you all.